it's necessary to see that you've got 3 squared minus 2x squared dx. So this is the a squared minus the x squared form, so that tells me it's sine. So 2x is equal to 3 sine of theta. And then if I'm going to solve for the x, and then remember, the most common mistake is to forget to find the dx and then forget to put it in, right? So we don't want to do that. So cosine of theta d theta. So dx is 3/2. Let me just use a different color here. Is 3/2 cosine of theta d theta. And inside the radical, you are looking for an identity, because that's how we can get rid of the radical. So 9 minus, so this is where I want you to be careful. For 2x, put in 3 sine theta. 3 sine theta squared. Okay, let's fix that in here. 9 minus 9 sine squared, 3/2 cosine theta d theta. Okay, so let's think about this here. I can factor out the root 9, and inside the radical I'd be left with 1 minus sine squared, and then this still carries along. Okay, so you know that root 9 is 3, and I'm going to pull this 3/2 outside just to get rid of the numbers. Inside the radical, 1 minus sine squared is cosine squared. This cosine carries along. And you know, let's carry this 9 over 4 here. You know that square root of cosine squared is cosine times another cosine. Oh, that's really messy. Let me fix that. That gives us a 9 over 4 cosine squared of theta. And then how do you do that? Well, you need the half angle formula, which you have memorized. So that's 1/2 1 plus cosine of 2 theta. Okay, so I'm going to make room and bring it back up here so I can keep it on the same page. So I'm going to I just put in the half angle formula. I haven't taken the antiderivative yet, so let's keep doing that. Okay, so I'd have 9 over 8, and then take the antiderivative of 1, that'll give me a theta. Antiderivative of cosine of 2 theta using La Jolla theorem, plus a c. Okay, I need to get back to x's. So that's where it's triangle time. So where does the triangle come from? The triangle comes from this, right? So I'm going to rewrite this as 2x over 3 is sine of theta. So rewriting that with here's my angle theta. And then I'd have opposite over hypotenuse. This side here, if I use the Pythagorean, would be 9 minus 2x quantity squared. Oh, yep, that was the original problem, right? So now I'm going to go to the triangle. Oh, wait a second. I can't get sine of 2 theta off the triangle, so that's where I used that other identity I said you need to have memorized. So that identity is 2 sine cosine plus a c. So you can see the 2's cancel. And so now I'm on the hunt to find out what's theta going to be. Well, I can take the inverse sine of both sides here. So I get inverse sine of 2x over 3 plus sine of theta. Well, that's just, right, sine of theta is just 2x over 3. And then cosine of theta would be, using the adjacent, 9 minus, I'm going to have to erase so I can fit it in, 9 minus 4x squared, that's the adjacent, over the hypotenuse, plus c. Wow, that was a lot.